Professor, Physician, Epidemiologist. I am Dr. Sri Banerjee. Hello, I'm Dr. Sri Banerjee, and in this segment, I'll be going over over the assumptions of the multiple regression analysis. Through this demonstration, I'll be focusing more on the assumptions and less on the actual statistical test. However, I do show you how to take the coefficients and the constant in order to make sure that the equation is sufficient and correct. Hello. In this segment, I'll be talking about how to conduct some of the assumptions from multiple regression in SPSS. So let's go ahead and get started. If we're trying to conduct a multiple regression, then the first place that you would go, of course, is analyze. And then going down, you would go into regression and then linear. And this is actually from an NHANES dataset, which one of my students used for their dissertation. So I wanted to create a regression model. This is a family poverty index ratio. So this is a marker of poverty. It's a continuous variable. And just to show you an idea, it was taken from here. And then age when they had the positive poverty income ratio, and then these are all continuous variables. That's why I selected them. They may not necessarily make sense, and I'm just trying to see, for instance, number of insensate areas on the left, number of insensate areas on the right, and how that affects family poverty income ratio. So these are predictors and these are outcome variables. Let's take a look at statistics and make sure that everything that's highlighted needs to be highlighted. The estimates, I think confidence intervals was not selected initially, and then model fit. So this is where you would find the R-squared, adjusted R-squared. But then you take a look at plots, and here this is important. Many places don't have this, so it's important that you keep in mind this plot, and we'll be interpreting that plot. So the plot here is ZRESID, and then this one is ZPRED. So this is the residual versus the predicted. We're going to be interpreting that again. Take a look at save, then make sure options, and then you want to exclude cases list-wise, and then include constant equation, and then everything else is filled out. So then we're ready to select OK. And here are some of the plots that are available. And the assumptions I'll go over. One of the things I wanted to make note is a lot of these assumptions, especially the normality test of the dependent variable, is not necessarily, especially if you have a sample size greater than 20, then all of these normality tests are moot points. So let's take a look at what we have here and the interpretation of all that. So adjusted R-squared, that means that about 2.4% is captured of data is actually correct. So again, when we have multiple regression, you want to actually interpret the adjusted R squared, not the R squared. And the adjusted R squared, about 2.4%, which is 0.024 to 2.4%, is attributed to uncertainty in residuals. So the rest of it, 97% of this is attributed to uncertain variance. So only 2.4% is adjusted variance. So if we move forward here and take a look at some of these other values, then you can take a look at first the equation. And the equation is 3.606 is the constant, and then these are the coefficients. And you want to make sure that the coefficients actually make sense in the context of the constant and other things. So then you go over the residuals statistics, and a lot of these visuals will explain a lot. This is a bimodal distribution peak, and this is of the dependent variable, the outcome variable. Actually, this is the regression standardized residual. And here's the frequency. So this seems like a bimodal distribution. However, again, when the sample size is large enough, it's not very prudent to be looking at the dependency or the level of dependency of the outcome variable. So if we look at some of these scatter plots, the dependent variable versus the regression standardized residual, and this is one of the plots that we looked at, then if you look at the standardized residual, if it's staying the same, then there's homoscedasticity. If there's a lot of deviation, then there's not homoscedasticity to worry about. It's heteroscedastic. So this is homoscedastic, and that is because it doesn't change, the residual doesn't change up or down between different dependent variables. So now if you want to dig a little deeper and take a look at truly if there's any sort of the standard normal distribution is being followed, then you can actually retrieve some more tests here. So this is the Kolmogorov-Smirnov test. Let's go to Analyze Descriptive Statistics, Explore. And then we already have the dependent listed here. Dependent is PIR and you remember that from the other plot. And then let's take a look at some of the plots that are needed. Normality plots with tests. This is one that's not usually selected. So then select Continue. Look for options. Exclude cases pairwise. And then Bootstrap. And there's nothing there. And then make sure that the plots is what's selected, and then hit OK. Let's take a look at so right away you can see for family PIR this is significant. That means that this is not normally distributed. However, another way to look at this is the PP plot. Actually, the normal QQ plot. The QQ plot is also drawn to make sure that it's normally distributed. And some of the expected versus the observed actually look similar. So if we're finding that there's different outcomes, then we can make the determination as well based on this QQ plot. There is some deviation from normal distribution. However, again, normality is not absolutely essential sort of assumption. So you can ignore that if you especially have sample size greater than 50. So now that we have gone over some of the assumptions, I wanted to make sure that all of them were done. There needs to be a linearity between the dependent and independent variable, and you can easily do a plot on that. There needs to be normality in distribution, and due to central limit theorem, we can surmise that from looking at something that is a sample that has a high sample size. And then we were looking at homoscedasticity versus heteroscedasticity, and that's where you plot the residuals and take a look at by dependent variable, is there a deviation in residual plots. And then, of course, we went over linear relationship. You want to make sure that there's not as much multicollinearity. What that means is that does it make sense to have multiple variables within the independent variables which are independent of each other, or do you want them to be codependent on each other, the number of independent variables? If you answered that they need to be independent from each other, then you answered correctly, because if you have multicollinearity, a lot of times the significance is there just because there's multicollinearity. And you'll have incorrect results. So these are all of the major assumptions that are that comprise the multiple regression test. And then I went over some of the output. However, that's not the focus of this segment. Thank you for listening.